Alright guys, I'm just going to clear up one or two issues that I'm seeing in some of your homework. So this is part D of the homework from page 211. I've already gone ahead and assigned the oxidation numbers. Hopefully you're all okay with that. Go back and have a look at the videos again if you're not, and let me know. That should say -2 over there. Okay, so the next thing is to figure out what has been oxidized and what has been reduced. So what has there been a change in? There's been a change in the chlorine oxidation number, and there's been a change in the manganese oxidation number. So chlorine there has gone from -1 to 0, so that's an increase in oxidation number, which means it has been oxidized. And what has happened to go from -1 to 0? What has happened to it? It has been, it has gained an electron. It has not, it has lost an electron. So it's -1 electron, sorry. The brain must be half asleep. And manganese has gone from +7 to +2, so it has been reduced and it has lost, it has gained electrons, sorry, +5 electrons. Saying it all the wrong way around. +5 electrons. And so what we're going to do now is we're going to take that 1 from the oxidized substance and we're going to put it in front of the reduced one in our equation. And we're going to take the 5 from our reduced substance and put it in front of the opposite substance. So now everyone, I think, seems okay as far as there. The issue comes with balancing the equation properly. So I'm just quickly going to draw out my box to balance it. And there is something, this isn't your fault. I should have probably mentioned this in the last video. I just didn't think of it. So if we take manganese, oxygen, hydrogen, and chlorine that we need to balance, I've got 1 manganese, 4 oxygens, 1 hydrogen, 5 chlorines. I've got 1 manganese, 1 oxygen, 2 hydrogen, and 2 chlorines. So manganese is balanced. I won't be touching that. Oxygen is not. Oxygen, I've got 4 on the left. I need 4 on the right. So I'm going to finish balancing that off. So I need a 4 in front of my water to give me my 4 oxygens. And that has also changed my number of hydrogens. I've now got 8. You don't need to worry about leaving oxygen and hydrogen to last as much in this. They should be easy enough to balance, but again, you can if you want. My hydrogens here are going to balance out. It might help to balance them first, actually, because usually the problem that you're going to see arises with one of the substances that is oxidized or reduced. Hydrogen, I've got 8 on the right, so I need to multiply by 8 on the left to even them out. So 8 on the left. And now everything is balanced except for chlorine. And what you'll notice is it's not a straightforward thing to balance. I've got 5 chlorines on the left and I've got 2 on the right. What I can't do here, what I'm seeing a lot of people do to make it easier for themselves, is to say, okay, I'll multiply this by 5 and I'll put 10 over on the right, and then I'll multiply this by 2 to get 10 over here. The way I want you to think of it is that you have to do as few multiplications as possible. We cannot do that. We cannot multiply by 2. That is not the simplest ratio that we can get. So we're not looking for a whole number ratio here. You're looking for the simplest ratio. And the way to get from 2 to make it equal to 5 is to multiply by 2.5. So if you put 5 divided by 2, sorry, my pen's not working, divided by 2 into your calculator, you'll get 2.5. So that's what you need to multiply this by. So to get 5 here, we put a 2.5. We usually write it as a half rather than as 0.5. 2.5 in front of the chlorine, and 2.5 by 2 gives me 5. So now everything is balanced. You can then go one step further and you can multiply across the whole equation by 2 to get rid of that fraction, so that if you were to do that, you would be getting, if we put it in here, you'd be getting a 2 in front there, 16, 10, 2, 5 and 8. But what you'll notice there is all of the other numbers have doubled, but if we had done it that way first, we would have ended up with a 10 on both sides here, which would not have been correct. That is not balanced. That's adding in more chlorines to the right hand side than we need. So that's not going to work there. So the way to do it is to balance it with as few multiplications as possible, and then you can multiply by 2 at the end if you want. That would be encouraged in some circumstances, but you'll get full marks without multiplying by 2 here. So don't be afraid to use halves in your balanced equation. Putting in a half is perfectly fine, and that's what you should be doing. So the other thing I wanted to say that I didn't say in the last video, that I saw a lot of you doing anyway, was to check that your answer is correct by checking the charges on both sides. So we've balanced it now in terms of atoms, but we now need to balance it and make sure it's balanced in terms of charges. So you can see here, I'll put it in yellow, I've got a +2 charge here on the manganese on the right. I've got a 0 charge there, there's no charge, and there's no charge on the water. Here I've got 5 minus 1s, so that's -5. I've got 8 pluses, so I've got +8, and I've got -1 on the manganese. Excuse me. So I'm just getting that from the charges that are on the ions, and multiplying them by the number in front, by the coefficient. And if we're correct, because it's +2 on the right here, if we add all of this together, we should get +2 as well. And we do. 8 minus 6 is +2. So that means I've correctly balanced my equation. Some of you noticed your mistakes here because of this check at the end. And that's why. It's all about how you multiply out, that you can use these half numbers in your coefficients. We don't want to be doing more multiplications in our balancing box down here on the right than we need to. Hopefully that makes sense. Pop me an email if it doesn't. If you didn't know this beforehand, if you got this wrong in your homework, maybe look over those and just try to correct them. The other questions that issue came up in was question B and question F. There should be halves in those.